This will be a short introduction to the way that pitch and time work in music. So when we think about or talk about pitch, which is how high or how low a given note is, and time, the way that notes flow in order, we can often think of them as being a kind of Cartesian grid system here. So pitch is generally organized and talked about on the up and down dimension. Time is usually organized and talked about on the left to right direction. So higher pitches are towards the top, lower pitches are generally represented or thought about as being low or down below somehow. And time, just like in written English or French or a lot of Western languages, moves from left to right. In practice, we've got a couple of technical ways that we represent these things. We organize pitch on a representation called the staff. The modern staff is 5 lines. You have some sort of clef here, which is going to tell you which note is which. So this is the treble clef, sometimes called the G clef, because a lot of the treble clef surrounds the note G. Each of the lines and spaces on this clef is a single unique note. And there are any number of mnemonics that people use to sort of remember which notes are which. For example, the classic, every good boy does fine, for the notes that are on the lines. Or a lot of people like to remember that the spaces spell out the word face with F-A-C-E. So you'll notice we only use a very limited alphabet from A through G, and then we start over as we're describing pitches. This brings up an important distinction that a pitch refers to a specific note in a specific place. So really, we mean this low E here is different than this high E up here, and that would be different than an even higher E or an even lower E. For bass notes, we use a different clef, the bass clef, or sometimes the F clef because of the position of the 2 dots that show us where the note F is. Then just the same, we can sort of fill in the rest of the clef. We can fill in the notes centered on that F that the clef shows us. And again, same limited number of letters from A through G, spelled out a little more clearly this time. And both of these staffs can have extra notes either above or below. So for example, this is an E below the staff, or this would be a C above the staff. And these are called ledger lines. So this is the way that we conceptualize pitch from top to bottom. Pitch refers to how high or how low an individual note is. And as we'll talk about in the next video, pitch also is one of the chief acoustic characteristics, along with a couple of other important things to think about. But this is the way that we conceptualize and talk about musical space. If we want to get a little bit more detailed, or perhaps a little bit more metaphorical, we can think about the ways that melodies are put together a little bit. So for example, in the classic song Frère Jacques, This one little excerpt just goes Frère Jacques, Frère Jacques. We can think about notes that are on adjacent lines or spaces as being a step. They're one of the smallest possible movements. And you can think about lines that are separated as being a leap. So melodies are often stepwise. Leaps act usually in predictable ways, but they serve to break up the monotony of something that just moves around by step. So we can think Frère Jacques, Frère Jacques. If we think about the melody a little bit larger, we can see that it steps up, then it leaps back down to where it came from, then it repeats exactly that movement again. Step, 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 leap. Even larger than that, melodies usually represent some sort of a repetition or variation on one another. We have one idea, and we have a second idea that's exactly the same thing. Then if we were to go on after that, drawing a very crude little treble clef here, we would see that the next thing the melody does is that it goes up and does the same thing a few steps higher. You know, Frère Jacques, dormez-vous, dormez-vous. So, the melody uses steps and leaps, the melody uses repetition, and the melody uses variation. And this is how all melodies are put together. These are very, very basic building blocks, but really they lend themselves to infinite variation. All of the melodies, all of the pieces of music, all the pop songs, all the film scores and video game soundtracks, all of their melodies use these basic ideas. They use pitches organized according to a few basic principles. They also use time organized into certain basic principles. At the lowest level, we can often think of a beat. This is simply where you would tap your foot. A lot of times the beat is very simple or intuitive. It's sort of the most obvious unit of time. So in that case, Frère Jacques, each note falls on a beat. 1, 2, 3, 4. 1, 2, 3, 4. The speed at which beats move is called the tempo. And we often represent this as beats per minute. So you could have a piece of music that is as slow as 40 or 50 or 60 beats per minute. A lot of times your heart rate is around maybe 80 beats per minute, 70 beats per minute if you're sitting still, 120, 130 or more if you're exercising. So you kind of have this intuitive grasp of how a beat works. And in music, you might even find beats that are up to 180 beats per minute. But eventually it gets too fast to tap your feet, and that's when you have to start thinking about the beat at another level. We often describe the relationship of an individual note's duration to the prevailing beat of a piece of music through a series of symbols that convey note length. A couple of the most basic ones are the whole note, the half note, the quarter note, and the eighth note. So these can sort of expand and contract in either direction. You can have notes that are longer than a whole note or shorter than an eighth note, such as a 16th note. But these are some of the most common ones. Essentially, this is a system in which each smaller note is half the value of the previous one. The whole note often, though not always, gets 4 beats. The half note usually gets 2 beats. The quarter note frequently has 1. Eighth note has sort of a half a beat. 16th note gets a quarter of a beat. So each successively smaller unit is usually twice as fast as the previous one. Now I say usually, but not quite always, because the length of a given note is dependent on the particular meter that we're working with. So this is one of the most common meters. It's called 4/4 time. We know that it's 4/4 because of this pair of numbers, which is called the time signature. And this is going to give us 2 pieces of information. The top number is telling us that there are 4 beats per measure. So the top number always tells us the number of beats in a given measure. The bottom note is telling us what kind of note gets the beat. So in this case, there are 4 beats per measure, and the number 4 means that a quarter note gets the beat. So again, this is the most common one, that 1 beat equals 1 quarter note. If the bottom note were, for example, a 2, that would mean that the half note gets the beat. If the bottom note were a 1, which is very rare, that would be the whole note. So this is why 4 represents quarter, because 1 would represent whole, 2 would represent half. Going even further, 8 would represent an eighth note getting the beat, and so on and so forth. So to look at some other common ones, 3/4 time. This is usually used for waltzes. It would go 1, 2, 3, 1, 2, 3. 3 beats per measure, and still the pulse is a quarter note. Another common one might switch things up a little bit. 6/8 time gives us 6 beats per measure. But eighth note gets the beat, which means we count this as 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. For various historical and aesthetic reasons, beats tend to come, or meters, tend to come with beats that go either in groups of 2s or 3s. So this means, 2 or 4, 3 or 6. Usually these numbers of beats are sort of divisible or symmetrical in some way. They're either 2s or 3s in some sort of a combination. That's been true very frequently throughout the history of music, though it doesn't hold across all styles or all time periods. It's also possible to have irregular meters that might give us a different kind of sense of the beat. So for example, 7 beats per measure, but eighth note gets the beat, gives us a beat that goes 1, 2, 3, 4, 5, 6, 7. And if we think about where the accent falls, where we might sort of group these together, we get something that's irregular. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. A lot of times, especially in film scores or game soundtracks, this is used to convey a sense of imbalance. The meter can't be divided up evenly. It doesn't really follow the typical metaphors of, a marching on the beat or waltzing to the beat, this kind of regular alternation of physical movements. Instead, it's irregular. So that's something to be aware of, whether a given meter or beat of a piece of music is used regularly or irregularly. So that's just a quick introduction to the ways that we talk about pitch, how high or low a note is, and represent that, and the ways that we talk about rhythm, how fast the music goes, the tempo, the beat at which we want to tap our feet to keep track of the tempo, and finally the meter, which is the particular way in which the piece of music is organized. I want very quickly, in fact, to go back to look at Frere Jacques now that we've talked about meter. The way that this one goes is 1, 2, 3, 4. Then it repeats 1, 2, 3, 4. So that the strongest accent is always here on the downbeat. There's usually kind of a secondary accent on the midway point of the measure, so that we can see the important parts of the melody are Frere Jacques, Frere Jacques. So it's no coincidence that the way this is put together is with the strongest note of the melody down here on beat 1. Sort of the second most important is the top of that upwards movement. Then we're going to leap down in preparation to start that movement again. Going up to the top, then leaping back down on a weaker beat. So this is the metric organization of this tune.